Let us take a look at the theoretical definition of probability. Probability is a mathematical tool used to study randomness and chance of an event's occurrence, while statistics is a form of mathematical analysis that uses quantified models, representations, and synopses for a given set of experimental data or real-life studies. Probability and statistics are actually extensively linked because statistical data are frequently analyzed to see whether conclusions can be drawn legitimately about a particular phenomenon and also to make predictions about future events. The link between probability and statistics can be applied to a wide variety of fields that deals with numbers. This brings us to the next topic of discussion, its usage. Commonly seen every day in our news telecasts, the weather forecasting heavily depends on probability and statistics. Another common use of probability and statistics is in the field of sports. Athletes and coaches use probability to determine the best sports strategies for games and competitions. This way, your favorite sportsman or team will be able to land that perfect score for your winning bet.
Next, what is normal distribution? Normal distribution is also known as Gaussian distribution. It is a probability distribution that is symmetric about the mean, showing that data near the mean value are more frequent in occurrence than data far from the mean value. Next is properties of normal distribution. It consists of bell-shaped curve graph. The mean, mode, and median are all equal. The curve is symmetric at the center. Exactly half of the value are to the left of center, and the other half are to right. The total area under the curve is 1. There are also few formulas under normal distribution, which are density of the normal random variable x, area under normal curve, transformation, normal approximation to binomial, and area under normal curve to the left.
Next is binomial distribution. It is used when there are exactly two mutually exclusive outcomes of a trial. Outcomes are labeled as success and failure. The binomial distribution with parameters n and p is the discrete probability distribution of the number of successes in a sequence of n. It is also divided into three subtopics. First, Bernoulli process is a single success or failure experiment and a sequence of outcome. Each trial results in an outcome that may be classified as a success or failure. The probability of success, denoted by P, remains constant from trial to trial. The repeated trials are independent. Second is the Bernoulli process. It is the number x of success in n Bernoulli trials. Bernoulli trial can result in as probability of success equals to probability of failure, and formula for the binomial probability mass function is as given. Third is binomial sum. Following are four conditions for binomial probability sum. Next is Poisson's distribution. It is the discrete probability distribution of the number of events occurring in a given time period or space. According to the formula, lambda is given as the average number of times that event occurs over that time period. The number of successes at a random point of time or space is determined. Following are the formulas of Poisson mean, Poisson variance, and Poisson probability sum.
Let's proceed to explanation on how Poisson distribution will be helpful in daily life applications. Poisson distribution is very useful in business. Companies can use Poisson distribution to inspect how they might have the option to find a way to improve their management operational efficiency, finds way to spike up their sales and collect competitive intelligence data.
Now, let's look at how to solve this question. A company makes electric motors. The probability an electric motor is defective is 0.01. What is the probability that a sample of electric motors will contain exactly 5 defective motors? Firstly, I will explain all the formulas that we are going to use in solving this question, and I will extract out the information given. Firstly, Poisson probability sum, and next is Poisson distribution, where lambda equals to average number of outcomes per unit distance, area, time, or volume, and exponent E is given by 2.71828 and so on. Mean and variance of Poisson distribution given as mu equals to variance equals to lambda. Secondly, from the question x is equals to 300, probability of success equals to probability of defective equals to 0.01. Probability of failure is 0.99. Lambda t is unknown.
So, to find lambda t, formula used is mu equals to n times p, which is equals to 300 times 0.01 equals to 3.
Next, fill up the Poisson distribution formula using all the values found just now. The equation can be solved by using the calculator. Therefore, the probability that a sample of 300 electric motors will contain exactly 5 defective motors is 0.10082.